Okay, so how does induction work when we're talking about creating a current in a generator? Well, there's a couple different ways you could create a current in some coils of wire. Imagine that the blue light is a magnetic field and it is going into the board. So it is going perpendicular to the board. So there's a couple ways I could change. I could create a magnetic force in the wire. I could change the strength of the magnetic field by making this stronger or weaker, which is what goes on in transformers. But we're not talking about transformers, we're talking about generators. So I can change the field a number of ways. Now, the thing to remember is it's not about how much magnetic field is going through the loop, it's about how much it changes. So I have to make a change. I can make a change by getting closer to the source. See, a lot more going through, less going through. I could pull it out of the thing. Now there's none going through. But the way that's the motion that is the most natural for a machine would be rotation. So if I rotate it, we got flux going through, and the amount of field goes through. Now there's nothing going through. Now it's going through, but since the coil's oriented the other way, it's going the other way. So this, now by the way, this is a very natural movement for a machine. Rotation is not really easy for the human arm. But this is what basically goes on in a generator. So it's not about how much is going through, it's about how fast the amount going through changes. So standing like this is the maximum amount of magnetic field going through, but right now nothing's changing. So you would get no force pushing the electrons in the wire. Now if it starts to move, now the amount that's going through is changing. You're going to get movement of electrons in the wire, and that's going to be moving because we're changing. Look at all that changing here. Now we're getting bigger, we're getting bigger, we're getting bigger, but then we start getting smaller. Now, as long as it's getting bigger or smaller, it's changing. It goes positive, it's positive, it's positive, it's positive, it's positive. Now it's negative, it's negative, it's negative, it's negative, it's positive, it's positive, it's positive, positive, negative, 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 negative. The forces are reversing. It's alternating back and forth. And that's how we're getting that alternating current. Now, there is one point where we get no current at all. And that's when it stops changing. Now, okay, so imagine, okay, so right now we're getting a positive voltage as it changes, it changes, it changes, it changes. It's still changing that same direction, changes and changes and changes and changes. But now, at this point, it's got to start going the other way. And so the current reverses direction. The current, if a current's going to reverse direction, there is a point where one moment the current was going one way, eventually it slows down, starts coming back the other way. There is a moment when it's no longer going one way, but before it started going the other way, for a split second, there is no voltage and no current. Now, by the way, you get your biggest transition, like when you're going from about here to there, right? But going from here to there is not a big difference, is it? From there to there, not very big. From there to there, that's pretty big. So when do you get the least change? Is when the wire, the wire is pretty much perpendicular to the direction of the magnetic field. When we pass through, that's a very fast change. But it's when we're right about perpendicular to magnetic field, that's when you're getting the smallest amount of change in the amount of magnetic field going through, and that's when you're going to get your smallest voltage and your smallest current. So I hope that's been helpful. So there, my arms are sore.